Okay, so the second example for mechanism of Friedel-Craft alkylation adalah yang ini. Okay, so kita ada benzene reacted with this structure here. I know this structure is quite complicated lah, kamu nampak kan? Tapi don't worry, ini kalau class of haloalkane ni adalah secondary lah, because carbon ni adalah carbon yang secondary. Okay, so maksudnya when this bond break, kita expect untuk dapat secondary carbocation lah. Okay, so if we get secondary carbocation, then no problem, because dalam video yang sebelum ni saya cakap kalau primary dan juga methyl carbocation tu yang problem kan, we need to form complex and just leave it as complex and bring it down to step 2. Okay, tapi dekat sini so kita ada secondary carbocation, so we can just simply break and form electrophile teruslah, which is secondary carbocation dekat step 1 kita. Tapi dekat sini, okay, for your information, mechanism of Friedel-Craft alkylation ada possibility for rearrangement. Okay, so the second example yang saya pilih dekat kamu ni, ada possibility untuk rearrangement tu berlaku. Rearrangement ni maksudnya 1,2 methyl shift, 1,2 hydride shift yang kita ada jumpa dalam topik alkene. Okay, exactly the same. Right, so over here what happen adalah di Cl kita break kan. Okay, so imagine Cl ni keluar. So the carbon here adalah secondary. So dia akan jadi secondary carbocation. Okay, tujuan kita buat rearrangement adalah to get more stable carbocation. So we know that secondary carbocation is less stable compared to tertiary carbocation. That means if we can form tertiary carbocation, kita akan prefer untuk form tertiary lah. So we need to look, what if we change the position of carbocation here to this carbon here. So this carbon bonded dengan satu carbon, so dia akan jadi primary carbocation, which is lagi unstable dari secondary. So tak naklah shift dekat sini, so kita cancel. So kita shift this carbocation to this carbon here. Okay, so this carbon sini adalah carbon yang tertiary, because dia ada attach 1, 2, 3 carbon. So this carbon adalah tertiary carbocation. So if we gerakkan dia pergi sini, dia akan jadi tertiary carbocation. So lebih stable. Okay, and then that is the reason why, as you can see, the major product is this one. That means our benzene ring is bonded to this tertiary carbon here. Okay, so that's why saya dapat structure ni as major product. Okay, and then for minor product, my benzene ring bonded straight to this secondary carbocation lah. Okay, alright, so kalau dalam exam, without dia minta kamu buat mechanism, you should be able to determine the major product lah. So cara dia macam tadi, imagine we break this bond, we will form carbocation, and then imagine we shift the carbocation pergi to the next carbon kiri kanan. What happen kalau dia jadi tertiary? That means ada possibility for rearrangement. Okay, so this is our major product. So we will write mechanism for major product sahajalah. Okay, so kita tengok yang the first step, formation of electrophile. Okay, so kita ambil kita punya chloroalkane kita, reacted with our AlCl3, which is our Lewis acid, electron deficient species. That means our arrow will start from Cl to Al. Okay, because arrow kita start dari nucleophile to electrophile. That means our product will be Cl attached to AlCl3. So Cl tinggal 2 lone pair sahaja, and this Al is negatively charged. Okay, while this Cl is positively charged. Okay, so this whole thing here, this is what we call complex. Okay, but we can break this complex, because when we break this complex, kita akan jadi secondary carbocation yang stable. So tak ada masalah lah dekat sini. Right, so we need to show arrow kita break the bond. Okay, so arrow kita nak break this bond. Okay, so this is carbon, this is Cl. So siapa dapat elektron? Obviously Cl lah, sebab Cl more electronegative. So our product will be this structure here. Okay, but over here ada carbocation. Okay, and then Cl, Al, Cl3 negative. Over here dah ada 3 lone pair. Okay, so this is secondary carbocation. Okay, and then this secondary carbocation is unstable lah compared to tertiary kan. So kita boleh shift lah, kita boleh shift terus. Okay, so kita kena fikirlah nak shift apa. 1,2 hydride shift ke 1,2 methyl shift. Okay, so we know that this carbocation kita akan gerakkan kat sini. But actually over here ada satu hydrogen. Okay, so carbocation pergi sini. So maksudnya this hydrogen kena pergi atas lah. Okay, so since kita gerakkan hydrogen, so that is what we call 1,2 hydride shift. Okay, so kita dah shift hydrogen. Alright, so our structure dia jadi tertiary carbocation sini. Okay, and since kita punya drawing dalam bentuk skeletal, so you can show the hydrogen sini or you don't have to show pun okay lah, kita faham je. Okay, so this is my tertiary carbocation which is electrophile kita lah. Okay, so this is baru step 1. Okay, kita dah form electrophile, that means we will go to step 2. Okay, so the next step is step 2, formation of uranium ion. So we have our benzene ring reacted with our electrophile yang kita form tadi selepas rearrangement, iaitu tertiary carbocation. Okay, so our benzene ring is electron rich area will go and attack this carbon here lah. Okay, so your arrow mesti sharp to this carbon. Okay. Alright, so it shows that the pi bond dekat benzene ring tu will break. Okay, so this is the pi bond. Okay, and then when the pi bond break, it will form a new bond with this structure here lah. Okay, so we need to redraw that structure. Okay, so this one. Okay, right, so this is our carbocation. Okay, and then we need to show the localization of pi electron tu. Okay, so that we can see the resonance structure. Okay, so the new double bond here. Okay, this is double bond yang remain. Okay, and then this whole thing pun masih sama. Okay, and then the next step adalah this pi electron move to this bond here. Okay, so we will form another resonance structure. Double bond baru sini. This is double bond yang dah lama lah. Okay, and then don't forget our carbocation. Sorry. Okay. Alright, so we need to label. This is our uranium ion. Okay, so step 2 tak ada masalah. Saya laju dah sebab sama je macam before this. Once we have our electrophile, attack lah and then show our resonance structure. Okay, so the last step is step 3, deprotonation. Okay, so tujuan kita deprotonate so that we can get back our double bond so that this benzene ring boleh jadi aromatic ring balik lah. Okay, and then other than that, we need to form back our catalyst AlCl3. So that means this bond here will break. Okay, macam before this. So bond ni putus and then this Cl will go and get hydrogen. Okay, and then the bond between C and H break to form a new bond which is pi bond dekat benzene ring. So our structure will be benzene ring bonded with this structure here. Okay, and then HCl and we get back our AlCl3. Okay, so this is the mechanism for major product. Okay, so point to take note here adalah, okay, kalau kamu jumpa structure yang bila Cl dia keluar, dia form secondary carbocation ataupun tertiary carbocation, you can break the complex. Okay, that means once you form the complex, kamu boleh break the complex. Okay, but if macam tadi primary dengan methyl carbocation tu dia unstable, so you cannot break the complex, you need to bring down the complex dekat step 2. Okay, and other than that, Friedel-Craft alkylation ada possibility for rearrangement. So you have to check lah once you form your carbocation, ada tak possibility for your carbocation tu jadi tertiary carbocation. Okay, so kalau ada possibility, then kita akan buat rearrangement. Okay, so for rearrangement, macam biasalah kita ada dua pilihan, 1,2 hydride shift or 1,2 methyl shift. Depend on apa yang kita nak gerakkan. So over here, this carbocation move to here. So if this carbocation move here, this hydrogen kena gerak lah. So since kita gerakkan this hydrogen, that's why dia nama dia 1,2 hydride shift. Okay, so I think that's all for mechanism of Friedel-Craft alkylation of benzene, and that's all for chapter benzene. Thank you. Bye.